So let's make a quick review. بسم الله الرحمن الرحيم. We started talking earlier about flow control and said that any program is linear in execution, and sometimes we need to take a decision which makes the program goes in one of two directions, like student pass or student fail, something like that. So this
Right.
is a flow, an instruction followed by instruction, followed by instruction, followed by instruction, etc. And it could be case when we need branching, so an instruction, could an instruction, goes to take a condition, and based on condition, we go in one direction and continue in it, or another direction, and uh, continue in it, the other one. Give me a second. Height. Floating waiting panel controls. Okay. And there is also looping, where you start by an instruction and another instruction, third instruction, and then based on a condition, whether there is still more work to do, you repeat some part of the work. More work to do, you repeat part of the work. Until there is no more work, you exit the loop and continue as per normal. And the branching is done using if statement. The statement syntax is if, then parentheses, condition. Condition is within between parentheses. And there is we have then the body. The body is executed if condition is true. Otherwise, we do nothing. Like when you want to save a photo, you first check if there's something with the same name, you delete it and save the new photo. If there's nothing with the same name, you do nothing and you delete nothing. You just save the photo to a file. And the if condition, if struct has a body, the body is either a statement ending in semicolon or a block of statement or more between opening and closing brackets. We said that all earlier. And we give some examples. If A equal, if we have some variables, A equals 5, B equals 7, C equals 7. Then if A equals B, this is false. Then the body, this is a body, will not be executed, will print nothing. Um, and this body can be one sentence or one statement, sorry, or two statements or more between uh, um, curly brackets. So either one statement and statement ending in semicolon or opening and closing brackets containing zero or more statements. Second variant is if-else statement, which has a syntax similar to the first one. If and condition within brackets, we execute body one, then else we execute body two. So one of the two bodies will be executed, either body one or body two, whether based on condition whether it's true or false. So in the similar condition, similar example, if we have else, we will added, else body contains the system output line, they are not equal. So one of them will be evaluated because A is 5 and B is 7, they are not equal. Then the else statement, the else body will be evaluated and the statement, the sentence, they are not equal is printed. Similar here. Okay, we have this exercise if integer equal 7, equal 5, if A equals 7, which is false, it will print nothing. Okay. Now, what if we have more than two pathways? We will use multiple if statements. I think we stopped here last time.
Uh, I think we stopped, yeah, around this point, maybe a bit further.
Either here, yeah, either here or at switch. Anyway, yeah.
Yeah.
So if we have more than two pathways, we use multiple if statements. Multiple if statements. We start with checking or testing or evaluating one condition. Whether it's true, you do its branch, go to its branch, or false, you evaluate the second condition. True, you evaluate, go to its branch. False, you evaluate the third condition. True, go to its branch. False, evaluate the fourth condition. True, go to its branch. False is the last one. We go to the last condition, last branch. And it's important here to notice that the whole last if statement with its if and else is included in the body of the false of the, I mean else of the previous statement, previous if statement, and the if statement, sorry, it's previous statement as a whole is included in the false, I mean the else branch of the previous statement. And the previous statement as a whole is included within the else of the first statement. That means we will never reach here until we know that, I mean, in condition three, until we know that condition one and two are false. And we'll never reach condition four until we know that, unless we know that condition one and two and three have been evaluated and all of them are false. But we can, if condition one is true, we go to this branch. This condition can still be true, but we did not even reach down to it because we already exit the multiple branching structure or construct from the first branch. Is that clear?
Mhm.
Okay. This is how we can write it. So multiple if statement can be nested. This is actually the exact meaning of nesting. This, as you see, this is nested inside this, and this inside that, and this is nested inside that. So multiple if statements can be nested. The else block in multiple if statements belongs to the last if statement. With the else here, I refer to this else.
Mhm.
And a simple and famous example is if you take the score of a student and print a sentence that represent its grade in degree in wording in words. So we take from the system standard input system.in. You open a scanner and take the next int. Next int, if the score is 100, this is perfect score. You print perfect score. Otherwise, you go to the else. In the else, we start with if. Uh, uh, if score equals greater than or equal to 90, we print very good. Else, that means it's neither 100 nor even greater than or equal to 90. That means it's smaller than 90. Uh, we go to the next if statement. If it's greater than or equal to 75, we print good. Otherwise, it means it's less than 75. If it's greater than or equal to 50, print plus. Otherwise, it means it's all of these are false, so it's lower than 50, not even equal to 50. So print fail. Yes, I remember now. Last session, we showed how the if statement, multiple if statements nested uh, are uh, aesthetically arranged, and also how they are actually um, evaluated. Although they might look um, below each other, they're actually indented within each other. Okay, second way to go to branch into several branches is through switch case. This is the start of today lecture. That means the new lecture for today.
Sounds good.
Switch case can be used instead of multiple if-else statements, and it takes an integer expression. It doesn't take a Boolean expression. So it doesn't take something like if a greater than 5. It
Mhm.
takes the expression is itself integer, like 5, 6, 3, 1000, things like this. Okay.
Yep.
It must take an integer expression. This is important, and I will tell you later why. There's nobody, it's something which nobody tell why, but I will give you the explanation.
Okay.
Uh, so the condition must be an integer expression, not a Boolean expression. This is very important here to understand. If you understand this, it's fine. If you want to understand the explanation, I will say it, but it's not important for anybody to know it. Okay, let's take an example of if statement. Uh, Previously, when I explained this, when I gave this course, I asked the students to write a simple calculator. So let's do it now.
Okay.
Um, the calculator starts with um, mm, taking first number as an integer and second number as an integer as well, and it's doing one operation based on um, a choice. We have one or two. One you can enter one or two or three. One for um, summation, two for deduction, and three for multiplication. And enter the choice. The choice will be one or two or three. Okay.
Right. Okay. Yeah.
You take the choice in a variable called choice, selection variable called choice. So now you have int one, int two, and choice. If choice equals one, you print uh, variable one plus variable two equals the summation result. If the choice equal two, this is for um, uh, deduction. So
Mhm.
print first value minus second value plus the result of um, one minus two, first minus second. And the same for the third choice. Um, one times two equals one time the product of the two numbers. Else, if I enter anything else, I will write invalid choice.
Mhm.
Okay. Uh,
Right.
this else is interesting because it saves me falling into um, falling into some mistakes, logical mistakes later. Okay.
Like I'm doing class. Can you please be quiet?
Hello.
Hang on. Yeah, sorry, my bad. I just had to talk to my brother for a second.
Okay.
Yeah. Okay.
So until here, assume you are following.
Mm-hmm.
Let's do that on the IDE.
Okay, sounds good.
Yes. Do you see the IDE or only the presentation?
I only see the presentation. Yeah. Okay, I'm seeing the IntelliJ now.
Test if statement. We have it. I think I do. Yes, fine.
Okay.
So the scanner takes from the system in. What's there? Oh, look at the frequency unlocked. Okay. And then it takes the first variable in int one, second variable in int two. Okay.
Mm.
And then asks for one of three choices. One, two, three for plus, minus, and multiplication. Straightforward. Straightforward.
Yeah,
Yeah.
I
And choice is used to direct the application to one of three branches, and anything else will go to this branch. Certif. This. What is this? Uh, mm, This is not my key map. Give me a second, please.
okay.
Eclipse copy. Why is it working? Control version into version. Run statement. Okay. Building. Shouldn't take should not take a long time. Okay.
Okay.
And the first number, let's say 10. And the second number, let's say 5. And now 1 for plus, 2 for minus, 3 for multiplication. Enter choice, let's say 2. 10 minus 5 equals 5.
Mm.
Again,
Cool.
10, 5, 1. What will do? What will 1 do?
That will make 15.
Yes. 10, 5, 3.
And that will make 50, right?
That's right.
Nice.
10, 5. That choice.
Uh,
Okay.
okay.
That's fine. So this is multiple if statements.
Right.
Let's try to do this to repeat it using switch.
Right.
So this is if, this is switch. If, switch. Okay.
Okay.
Start by printing the same. Start and
Mhm.
take a choice, the same. Then switch choice. I think it should be. I need. I try to make the code as stable as it is, but then. Okay. Anyway, then switch on choice. I have to switch to the bar. Maybe one yes. I take the choice and switch on the choice. Choice is an integer expression. It's not a Boolean expression. It's important.
Right.
Simply I said, I write case one, case two, case three, and default.
Right.
Case one, we put all the same statement and end with break. Case two, same statement, end with break. Case three, same statement, end with break. Default, same statement. No need for break.
Right.
And the whole switch struct is included between opening and closing uh, brackets, curly brackets. Okay, very similar
Mm.
to what's here, very similar.
Yeah.
But the boilerplate code is less.
Right.
Okay,
Okay.
let's see that and then continue.
Mhm.
Switch case, switch case, switch case. Let's put it this way, this way. You see in the beginning, there's no difference
Yep.
until this line. And
Right.
then switch on choice versus if choice equals 1. Same sentences, but in a different struct. Let's see that and see what's happening. Switch case. Interface number, then second number. 5, 1, 15. Then 5, 2 will be 5. Then 5, 3, 50.
Mhm.
Then 5, 4, that's choice. Same behavior.
Yep.
Okay. Then why do we need or why do you choose multiple choice? Multiple choice using switch.
Mm.
This is a legitimate question. If they both have the same behavior, apparently, and they look similarly, almost the same, why do we have switch? But before we say why we have switch, let me give you another piece of information. The word is the keyword break here is essential. It's not important. It's essential. It's vital.
Right.
And the difference between vital and important is big. Okay.
Right,
It
definitely.
it will give you a hint on the way for statement for sorry if statement or if construct work and switch case construct works. Break is important, and without it, it happens what we call false row. False row means you finish what you have in this option and fall through to the next one. Next one. If there's no break, you will fall through to the third one.
Okay.
Okay.
Mhm.
Is this useful? Yes, sometimes it is. Sometimes it's useful. Sometimes actually needed. Let's give an example of a washing machine. Suppose that you have a washing machine with four choices only.
Mhm.
Heavy cycle, normal cycle, rinse only, sorry, rinse and spin only.
Right.
Okay.
Huh?
The the normal cycle start by washing, then rinsing, and then spinning.
Mhm.
Forget about heavy cycle now. Sometimes you have maybe you washed the thing uh, using um the clothes. I mean, using um, detergent by
Mhm.
by hand manually, and just want to rinse and spin. So you
Right.
can choose choice number three, or it even wasn't dirty. It was just uh, wet because you walked under the rain and you want to spin to make it less moist, almost dry. So you need only spin only. Agree?
Yep. Makes sense.
Nice. So the normal cycle includes spin and rinse. And the spin and rinse includes, sorry, rinse and spin. And the rinse and spin includes spin.
Right.
Okay.
Mhm.
And the heavy cycle is similar to normal cycle, but with different uh, parameters only. Instead of, so you may implement it in a way like this. Case one, which is a heavy cycle, you do washing for 3 minutes, 30 minutes, and rinsing for 20 minutes, or say 20 seconds, and then spinning for 10 minutes. This was the heavy cycle. The, the, and end with break. In the case of normal cycle only includes washing for 20 minutes, and you continue to the next step, which is rinsing for 10 minutes, and then continue for through to spinning for 5 minutes. Okay.
Mhm.
And then exit with break. If you want to enter from here, you can enter from here to the rinse and spin and do the rinse and continue down to the spin. So it's a construct with multiple entry points and multiple exit points. And if there is no exit point, you will continue from one case to the second, to the third, to the fourth, and fifth, etc.
Mhm.
When you meet the word keyword break, you you exit the whole construct. There are two breaks here. One here after case one, which is a uh, heavy cycle. or after case 4, which is the end of normal cycle and end of rinse and spin and end of spin only, all of them together.
Right.
Okay. So when you write your code, it's always a good practice to write a comment, and the comment you write false row, so that you remember it's a false row. Nobody coming later thinks that you forgot to write the word break, and even you remember, you remind yourself, I should not write for break here. It's a false row.
Right.
Okay.
Okay. Right. Okay.
Let's see this example. Where is the example? Where is the example?
Is it the washing machine.java?
Where is it?
It's
Yep,
the, yeah.
maybe. Let's put it here. There. And washing machine Java. Yes,
Okay. Yes.
we have a function called spin, which writes spinning for duration, minutes, and called rinse, which writes rinsing for this duration, and wash, which writes washing for this duration. Okay,
Mhm.
and we have the switch. We print the menu and take the choice in a variable, an integer variable called choice, and based on it, we either call wash, rinse, and spin with big numbers and break, or wash, then force row to rinse, then force row to spin with smaller numbers, 30, 20, 10, become 20, 10, 5, and end with break. And the fault is the same, invalid choice. Let's
Mhm.
run this. Control F, notion, washing
Right.
machine, build. Okay, let's say start with heavy cycle, 1. Okay, washing for 30 minutes, rinsing for 20 minutes, spinning for 10 minutes. This is a heavy cycle. Start by, let's go to normal cycle, 2. Washing for 20 minutes, rinsing for 10 minutes, spinning for 5 minutes. Although rinse, the call to rinse and the call to spin are in different cases. It fell through from case 2 to 3 to 4 until it met break, it exit.
Mhm.
Let's try 4 this time. Rinsing for 5 minutes only. Let's try 6 or 7. Invalid choice.
Right.
And invalid choice is followed by the closing bracket. So actually, there's no for break, no need for break. This behavior is not present in the multiple if statements. This is one difference. Second difference, I said earlier, is that you need, in order to reach this condition, or let's see, in order to reach this condition, you must test this condition first, and make sure that they are false before you arrive here. And here, you cannot reach it before you test this condition, this condition, this condition, and this condition, and they were all false in sequence. Okay,
Mhm.
so this is a series of Boolean expressions. This is one integer expression. Now
Right.
let's go to what is happening under the hood. And the next slide or two or couple of slides is advanced. If you don't understand them, I'm fine. If you understand this is 100% of what's needed from you. Okay? So don't panic if you don't understand the next two slides.
Okay.
No, not the two slides. This slide. Okay, okay. Then let's give it another example.
Okay.
Another example. You should understand this. This is mid difficulty.
Right.
Okay. Do you remember the simple calculator example?
Mm-hmm.
In the simple calculator example, we took an integer, 1, 2, or 3,
Mm-hmm.
right?
Right.
Nice. Now, do you remember the data types in Java?
Yeah, it's bit, byte, integer, uh double.
No, no, no,
Oh,
no,
it's
no, no,
float
no,
and
no,
double
no,
is
no, 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 no,
Boolean.
no, 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 no. This is not how the evaluate the division is. We have primitive and reference. As
Oh
primitive,
no,
we
I
have
thought.
Boolean,
Oh,
Boolean, integral, or integral, I'm not sure, integral and floating point. And with integral, we have byte, char, int, short, int, long, right?
okay, yeah.
And the char, both char and the short have 2 bytes. The only difference between them is that the char is unsigned, while the short is signed. Remember?
Oh
But
yeah.
both of them are integer expressions, integer, whole integer numbers.
Mhm. Okay.
That means char itself can be used as an integer expression.
Okay.
Agree?
Yeah, I think so. Yeah.
Okay, let's make a direct application of this. Instead of asking the user to enter 1 or 2 or okay, instead of asking the user to enter a choice 1 or 2 or 3, and then based on the number, we go to the corresponding branch. Why don't you ask the user to input the sign itself, plus or minus or asterisk? The plus is a character. The minus is a character. The asterisk is a character, right?
Mm-hmm.
So if he enters the character itself, it in itself holds a number.
Uh-huh.
So we can use it directly without needing to write 1 or 2 or 3.
Oh, okay.
So look here. Instead of asking the user to enter a choice and giving him one of the one for plus, two for minus, three for multiplication, I ask the user to enter the choice directly, plus, minus, or asterisk,
Okay.
and take the character. Like, look here, notice here that I didn't put it in int. I didn't use next int. I
Right.
used next and char at 0, put it
Uh-huh.
in a character.
Right.
And the character itself is an integer value. So I can use case plus, notice that the character, if when you write it in a literal, you write it between a pair of single brackets, not double brackets like the string. Double quotes is not double quotes. This is single quote. They are both present in the on the keyboard on the same key. You have the one to the right of the semicolon. You have single quote and double quote on the same key. One with shift and one without shift. You see it? On the middle line, you have A, S, D, F, G, H, J, K, L, semicolon, and then the next key contains single quote and double quote. Right?
Uh, yeah, I guess, yeah.
Okay. So this is how you write a character if containing plus. If you write it, if you put plus between a pair of double quotes, it will be a string. So don't fall into this. And I said that earlier in when I was showing the different types of data, different flavors. The slide was named this name. Anyway, so we can use here, we can use the value itself, the character itself. We say case plus blah 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 and break. Case minus blah 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 and break. Case asterisk blah 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 break and default print invalid choice.
Okay.
Let's try that. This should make the life even easier, I
Mm.
assume. Where is it? Switch case whisker. I assume this is the right file. Yes, that's the right file. Starting with the same start. Enter first number in int1, enter second number in int2, enter a choice plus minus or asterisk, and take the next, and from next take character at first character, put it in char ch. By convention, we use ch to refer to a character, and I to refer to int, and s to refer to string. Anyway, and switch on the ch itself, case plus, case minus, case asterisk, and default. Every case ends with break. Let's try that. Which one is this? Sorry. I'm not sure. This is our previous one. Sorry. And switch this. Okay, enter the first number, 10. Second number, 5. Now it asks me to enter plus directly or minus directly. Let me enter minus. It writes 10 minus 5 equal 5.
Mm.
Okay.
Right.
Before we go on, this is a character.
Right.
This is a string. So don't mix between the a tragic. This is a string, and it doesn't accept it here.
Okay.
Required type character provided string. Okay.
Okay.
Nice.
Right.
Let's continue testing. Mhm. 10, 5 plus 15. 10, 5 asterisk 50. 10, 1. Previously 1 referred to plus. Now 1 is not accepted. That choice. Okay.
Mm.
Why I'm showing this? Because I want to indicate that the switch statement, sorry, construct takes an integer expression. Okay, nice. Now let's go to the advanced part. This was the intermediate part. Did you get? Have you understand it?
Yeah, I think I understand it.
Great. Let's go to advanced part. What's
Okay.
happening actually under the hood? Why switch case needs integer? because actually under the hood it creates a table of instructions, of instruction addresses. Suppose that this is address of number 1000, this is address number 1050, this is address number 1100, and this address of 3000 used for otherwise. Okay, this
Uh,
first value, second value, third value. So it's a lookup table. You'll hear the word lookup table later. Most of you will not be with me. If you if you take the value plus, jump into the address 1000, and I'm using the word jump uh, deliberately. This is literally jump. In the
okay.
assembly, it's called jump. So if you see if you receive the value plus or whatever the integer value for plus, jump into 1000 and continue your linear execution. Is it linear? One, first line, second line, third line, fourth line, fifth line, right? And this, then when you see when you switch case, ask you to jump to an address based on a value. If you see 1000, jump to this line and continue linearly. If you receive minus, jump to this line and continue linearly. If you receive this value, go to this line and continue linearly, and otherwise jump to this line, which usually the last one, and continue linearly to exit the the the, the switch construct. That's why the break statement is important. If there is no break statement, it will continue this line, then this line, this line until it meets break. Did you get that?
Okay. I think I get it a little bit.
If you get 25% of that, it's a success for me.
Oh, okay. Nice. Nice. Do have one question. With those numbers, it says the address to jump to, those ones, are
Mhm.
those, do they have to be like 1,050?
No. Just examples. These numbers are just examples. The
Oh, okay.
application is a set of instructions in the memory,
Okay.
right?
Mm-hmm.
And set of instruction doesn't necessarily be one every 20, 50, or 100 or whatever. And one instruction line may be composed of one line in Java may may be represented as one line in assembly, or maybe 20 lines in assembly, according to how complex the line is. Okay, so
Mm-hmm.
you don't need to worry much about these numbers. It's memory address of the next instruction. And as you know that we all know that all the program is loaded in the memory before execution,
Okay.
right?
Mm-hmm. Okay.
مش عايز صوت. So that's why we write here the address of the instruction to jump to.
Oh,
Okay,
okay. Right.
nice. Uh, this is how the the is another example of the washing machine, how it works. Okay,
Mm-hmm.
nice. Now I will give you even more advanced piece of information before we go to that more advanced piece. Now you can understand that if you jump into case one, you will execute wash, then rinse, then spin, then
Uh,
wash for 30, rinse for 20, spin for 10, and then
and then break
break to exit from the
the
switch construct. Okay?
right switch.
If you jump here into wash, you will lose a wash and fall through to rinse and fall through to spin until you break.
Okay.
If you
Right.
jump into rinse, you will do the rinse and the spin and then break. If you jump directly into spin, you will only do spin and break.
Oh, okay. Okay. Yeah, I understand.
Okay, look at it. You can see it like as a fork, where you enter from the fork hand and then exit from one of the spines of the fork and continue down and continue down. Okay.
Okay.
Now the more advanced part here, I used characters plus, minus, and asterisk. Here I use just integers. And if the integer values are consecutive, this is a table, comparable table to the previous one, right? 1, 2, 3, 4, otherwise, right?
Yeah.
Now, here is the more advanced part, which makes which can make your program even faster. If those numbers are consecutive, 1, 2, 3, 4, or 100, 100, 100, 2, 1, 3, whatever, consecutive, the compiler can simply omit the left column
Oh.
and keep only this. What is it? And keep only this column and jump directly to the corresponding line without checking what is the content of this line. So
Mhm.
one, two, so 1, 2, 3, 4, 1, 2, 3, 4, and any value other more than 4.
Okay. Makes
This
sense.
is the second level of being advanced. If you don't understand that, it's fine, as long as you understand the force through part of it or of the whole story.
Okay.
Okay,
Okay.
nice. That ends the switch case story, and this end and switch case is the end of multi-branching. So now we have talked about branching, whether it's single branch or not, two branches, right or left, or multi branches to go in one branch and continue on it. Okay.
Okay.
Do you want to start talk about loops or keep it to the next week?
Uh, I have an online Quran class in at 4 actually, so we could do a little bit. Yeah. Maybe just a
Little.
little bit. We can touch on it.
Okay, let's take the overview
Okay. Sounds
and
good.
then start with the overview next time, inshallah.
Inshallah.
Okay, for loops, we need to repeat the same procedure multiple times.
Hmm.
Some examples here, like teacher enters the scores of his class students, first and second and third and fourth, until maybe student number 20 or 50, according to the size of the class. Or a robot keeps moving forward in the same direction until it reaches the target. Or a robot keeps rotating uh, until it faces a specific direction. Or a statistical application that is summing the entries. It keeps taking entries, and summing them until you finish all of them to start calculating the average. So it's repeating the same process several times. This is a loop. And there are two types of loops. Okay? If you understand
Mm-hmm.
that, then the whole loops will be piece of cake.
Okay.
There are two types of loops. First type is for predefined iterations, loop for predefined iteration. And second is for undefined number of iterations. And this is based on condition.
Okay.
Let me give you simple examples before we explain more. If I ask you, if I ask you to count the numbers from 1 to 10, is this a predefined number of iterations or not?
Um, I think that's a predefined because
Yes,
that's
exactly. Because I want to count from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are not 10 iterations. It will never be 9, it will never be 11.
right. Makes
If
sense.
I ask the robot to go to the target, this is an undefined number of iterations because the robot doesn't know exactly how the friction between the wheels and the ground is. The exact distance between the wheel and between the current position and target position. The battery and its output energy, which is reflected as work. These are all and others are factors which make the number of iterations not exactly known, but
Right.
it's known, but can be based on a condition. If I reached the target or not yet. If I didn't reach the target, I continue working, continue going. If I reach, I stop going forward. Agree?
Mm.
Nice. So the loops are either for predefined number of iterations and undefined number of iterations. The predefined are also subdivided into counting a counter or iterating over a collection.
Okay.
Okay? So I,
Right.
I have a set of students. I take the first and second and third. I know that they are 17 students. I will take them one by one. They will not be 16. I will not be 18. They are 17. Or I can count a counter. One from 1 to 17.
Mm.
From 1 to 17 will never be 16, will never be 18. Similar. Okay. Based on a condition, the condition can be defined within the loop or before or within the loop. This group, the left group, is usually in high level languages, including Java and others, is called for loops, and the right group is called while loops or until loops. Until is the opposite of while, which means while not. So loop until you reach the target is effectively equal to while you did not reach the target yet. Okay. So
Okay.
this is the overall um, the overall structure of the loops in general. Loops with predefined iteration and loops which with undefined iterations that will be based on condition. And the predefined iteration can be either by counting a counter or iterating over a collection. The other thing is by checking the condition, whether it is within the loop or before or within the loop. The first group is called for loops, and second is called while or until loops, or do while loops, whatever. Okay. Uh, if we start for loops now, we will no. Let's we should start for loop from the beginning of a new lecture.
Okay.
Okay. So let's stop here, and next week,
Sounds
inshallah, we continue from review the same slide, and do the for loops.
Inshallah. Thank you for having class today, brother Amr. As- Assalamu alaikum now. Goodbye.
Welcome. Alaikum salam.